In this session now, I am going to talk through, Ryan, everything that you need to know for your boat project, for the math part of your boat project. Okay? Hi, at home if you're not here. So, on the board here, this is our rubric. I'm going to give you a paper copy of this in a second, but for now, I'd like you just to look at the one that there is on the board. Okay? I am only going to go through level 5 and above, because that's what the at-grade level expectations are. So, and I'm going to go through examples on the board afterwards as to what you actually need to do. So, in order to get a 5 for knowledge and understanding, you need to have correctly calculated the entire volume of your boat. Now, this is your individual boat that you did yourself as your individual project at the beginning. The one that you're using for your science slides right now. It is not your team boat, okay? Your team boat may be one of those boats, or it could be an amalgamation of, different skills that you got from different people in your team, okay? So you've calculated the entire volume of your boat. Now the reason for that is because the volume of your boat is what makes it buoyant. Imagine this is my boat. Like, has anyone ever tried to push something that's full of air into water?
Yeah.
It's hard, isn't it? It doesn't like it. Why doesn't it like it? Science. Very good, Walter White. That's exactly right. So
That's physics.
the density of air is much less than water. So if you take like a soccer ball and you push it down into the water, it's very uncomfortable. It doesn't like being in there. This is what we call buoyancy. Now, buoyancy is incredibly powerful. And the volume of your boat is going to determine how buoyant your boat is. Later, we're going to discuss the buoyancy formula and how you can apply that. But for now, I'm really just going to focus on the basics to get you started. So you're going to work out the total volume of your boat. That means the outside of your boat. Doesn't mean any of the stuff that's inside, the gussets or whatever it is. It means how much volume can be pushed down into the water. Okay? The next thing you're going to do is calculate the area of cardboard that you've used. So, Lucas, I'm just going to go over here for a second. So, imagine your boat is made up of lots of different pieces of cardboard, okay? There they are. There's some rectangles. There we go. And there's a nice triangle. Lots of bits of cardboard. There's probably another one there. That would come together to make a boat. Everyone with me so far?
Yeah.
So I want you to work out what the area of that face of cardboard is. Yep. And then you're going to add all of those together. So, and the total area equals this in centimeters squared. Everyone with me so far?
Yeah.
Okay. Now, the reason that you need to know the area of your cardboard brings us to level 6. Okay?
No.
Because level 6 is, in addition to the above, you have found the weight of your boat using the area of your cardboard and its passenger, which would just be your mass. Okay? Now, you're not going to be building your boat. This is just the one you designed. So how are you going to be able to weigh it? Well, you're not. What you're going to do is you're going to make an estimate. You are going to go into the storage room and you're going to borrow a piece of cardboard, a real piece of cardboard. You're going to check what its area is and you're going to weigh it. So that's going to give you an area 1 and it's going to give you a mass of it. Everyone with me so far?
Yeah.
You're then going to look at what the total area of your boat was. Let's call that area 2. And you're going to use proportion. Just like we did in Unit 1. I know, it's again almost like I planned these things, isn't it? And you're going to look for what is that proportionality link that multiplies these. And you're going to apply the same link here to make an estimate for what your mass, which we'll call mass 2, is for your boat. Okay? And that's the first part of level 6. Now, I'm not going to talk about the buoyancy formula now. You'll see it's actually on the back of the piece of paper I'm going to give you in a minute, but we're going to talk about that next time. But you have calculated a height. You've applied your results to the buoyancy formula and you've calculated a height that the water will reach when the boat is floating. So very quickly, all I mean by that is, so Lucas up here, if this is a boat and it's in water, there's going to be a height that the water reaches on your boat. Is everyone familiar with that as a concept? And the more weight that you put on the boat, obviously, you know, that water line is going to get higher and higher and higher until eventually what would happen?
Titanic.
The boat would sink. Absolutely right. Okay? Is everyone happy so far? I mean, you're not happy with how to do those last two bits, but you're happy with the concept for knowledge and understanding.
Yes.
Okay, great. So, communication. So, you have designed a boat on a computer package and shown multiple views of it with the dimensions. Now, this bit I'm going to make crystal clear. Okay? So, you have all just created a Google slide. Okay? So, Lucas, can you see that clearly on there?
Yeah.
Okay, perfect. You've just created a Google slide. This is what you are going to do. Actually, I'll make that a bit bigger so maybe it's better for the recording. This is your first Google slide. You might want to do this on the first couple. It depends how many views you need. But you're going to take a screenshot of a couple of views of your boat. So why don't we use that boat that I did in class? So mine was a rectangular prism, and it had a cylinder coming out of here that I can breathe out of. So that was my design. Okay? Now what I want you to do is I want you to take a screenshot from multiple views. So I can do one here. There it is. There's my boat. Oh, beautiful. With my cylinder. I'm going to make that a nice high cylinder. And then you're going to embed some arrows. You know those little arrows you can do on Google Slides? And we're going to put those arrows in like this. So this is going to be 40 centimeters. This is going to be another 40 centimeters. And I'm going to make that 80 centimeters. Because when I'm in my boat, I like to curl up in like the fetal pose so that I'm in there like that. I'm expecting some stormy weather. So I'm going to make that another 40 centimeters for my cylinder. Okay? Then I'm going to have another view, which I'm going to put down here. This is from above. Because I also need to know the diameter of my cylinder, or radius, but in this case I'm going to do diameter, I think. And I'm going to call that 20 centimeters. And then maybe I can repeat a couple of these to make it super easy. So that's going to be 40 centimeters, and that's going to be 80 centimeters. And honestly, for me and my simple boat, I think that's all the measurements I would need. Because what I'm going to need later, when I'm grading your project, is I'm going to need to be able to check your calculations. So when you're calculating, for example, the volume of your boat, so you're going to go volume, and then you're going to show your calculations really carefully. You're going to write down rectangular prism. And then you're going to put the calculations down for what you did for volume. So for me, that is going to be 80 times 40 times 40, which is blah centimeters cubed. How clear is that? How easy is that for me to grade?
Very easy.
It's really, really easy. And then I'm going to do cylinder. And my cylinder is going to be, so what is that? Pi r squared h. So it's going to be 10, so it's going to be pi times 10 squared, because that's half of my 20, times h, which we said was 40 centimeters. And that is the volume of my thing. And then at the bottom, I'm going to show the total volume, which is whatever that is in centimeters cubed. Everyone with me so far?
Yeah.
How clear is all of that?
Very.
How easy is it for me to see the dimensions so I can check these bits?
Really.
Really, really easy. After I've done the volume, I'm going to do the area. And again, really, really clearly, I'm going to show what my area is. So for mine, probably the easiest way for me to do that would just be to make a net like this, because the net is going to represent all of the bits and pieces that I need specifically for that. And then I'm going to put down some calculations. Equals this, equals this, equals this. And then this is the total area. Oh, sorry, I need one rectangle for my cylinder as well. Is everyone familiar that a cylinder is a rectangle? Woo, mad, huh?
No way.
And then, so I've got my total volume, I've got my total area. Now this next bit, I'm going to be really, really clear. This is not me being mean, okay? This has to be clear for me.
No.
I've got 80 projects that I am grading. I'm just recording this, so you're going to have to wait a second. I've got 80 projects that I am grading. Let's say, just for argument's sake, that it takes me to check all your calculations, go through all your extensions, refer to the rubric, half an hour each. How much grading time is that?
Like a day.
I don't know.
40 hours. Too long.
40 hours. Now, don't get me wrong, I love you guys. I love making these projects. I think they're really, really worthwhile. But there are moments when I'm 30 hours into grading that I feel physical pain. I mean, literally, like coursing through my veins. So, how long do you think I am going to spend looking for dimensions that I cannot read clearly on your slides?
0.
I am not going to spend any time. I am going to spend seconds. And if I cannot see that dimension, then I'm going to assume that dimension is not there. And if I can't see your dimension, can I check your calculations?
Yes. No.
No. If I cannot check your calculations, can I give you credit for that?
No. You
I
get a
cannot.
0.
That's not me being mean. That is me saying that I also value my time. And you spending 5 minutes making it clear, I think that's a reasonable request for me to make. So has everyone understood that? So there's not going to be any crying and wailing and gnashing of teeth when you do not get the grade that you feel that you deserve. Because I am spending 40 hours grading these, and I'm willing to give you that, but I'm not going to give you a second more.
Okay.
And this, honestly, that's a pretty good lesson for life. You know, if you want to get things, out of people, whether it's the IB examiners that have got a pile of exams that big and they're getting paid 10 cents per exam, and it's 4 o'clock in the morning and they're grading it by candlelight, and they literally have nothing left in the tank, and you want to make their life easy. The same later on when you're working, the same deal. Make it as easy as possible. So, I may as well keep the recording going, but this is the sheet I'm going to give you all in a second. Is there anybody that has a quick question? Hi, Alexandra.
So this is about like the boat.
This is your individual boat. That is what you're going to be graded on. Are there any other questions right now? Hi.
When you do volume, like for example, you needed 2-point-something millimeter thickness, or
So for that, the volume does not matter. The volume is how much of the boat is going to get submerged in the water. Because ultimately, it's the amount of water that's being displaced, it's the amount of air that's being pushed in that matters. So the thickness of the cardboard does not matter. What matters is how much is there inside that boat. So it's basically the outside of that boat being pushed into the water. That's the volume that you need. So for me, it's the volume of that rectangular prism and the volume of that cylinder. Does that answer your question?
yeah.
Okay, great. Lucas, I think you can press stop.